Hello everyone, and thanks for joining us. Today we're going to go over the RS2 and the initial setup. Before that, we'll look at GNSS 101 just to make sure we're all on the same page. But then we'll jump into the first updates and setting up the RS2, and we'll follow that with a question and answer. So Event 38 Unmanned Systems was founded in 2011, and we've been supporting Emlid equipment and using Emlid equipment in our RTK systems since 2016. And with the popularity of the RS2 and the RS Plus, we really expanded on that and formed E38 Survey Solutions to take care of those customers and to expand that line. And there'll be a lot more coming, but we have expanded the line to offer microsurvey products, including Field Genius, authorized use of AppGloss, data collection software, and a couple different survey accessory manufacturers as well. And like I said, there's more to come. We're still pretty young on that side of things, but we are the biggest Emlid dealer here in the U.S. So jump right into Global Navigation Satellite System. That's GNSS 101. The satellite constellations make up the satellite system itself. So a lot of times we'll use GPS and GNSS kind of interchangeably, but really GNSS includes GPS and includes the GLONASS constellations and Galileo, Baidu, and many more. Really what we're concerned with are these satellite systems that cover the US. So we have those four main ones: GPS, GLONASS, Galileo, Baidu. And I would say that the older GPS or GNSS receivers out there might only cover GPS and GLONASS, and most of the newer ones are tracking all the satellites. And the RS2, fortunately, it's a newer one, and it's tracking all these different constellations that we really like, these global coverage constellations, and that's going to let us, I guess, maintain an accurate fix where maybe if we didn't have Galileo or Baidu, that we might not have a fix and have more trouble kind of gathering the positioning information we're looking for. So these global coverage systems, so they may have 30 satellites orbiting the world very specifically, and this allows the minimum satellites needed to kind of always be visible no matter where we're at. The regional coverage satellites, there's less of them, so they need to kind of stick to a certain area, so they have different orbits, for instance, covering Japan or India. So those we can kind of aren't important to us at this point unless they expand to the point where they turn into global coverage constellations. So these satellites are sending down information. They're sending down the location of the satellite and the time that they sent that message. So from there we can calculate distance, and if we have enough distances calculated, we can triangulate or trilaterate our position to get an exact position. But with GPS, unfortunately, there's all sorts of different error sources that can come up. So satellite clock errors, Earth rotating, atmospheric errors, multipath, and more. So we have to correct for those, and that's where the second receiver comes in. That's where these RTK corrections come in. And we can get these base corrections from a local base station. So we have two RS2s, one communicating with another over lower radio, or we can get corrections over NTRIP. So again, base rover corrections. With RS2s, we have internal LoRa radios that allow the base to communicate with the rover. So the base will again send those corrections over LoRa radio to the rover. Using NTRIP, we typically this is really just communicating over the internet, and most often when we talk about NTRIP, we're talking about signing up for some subscription to an NTRIP network provider, and these network providers have physical base stations all over the region you're looking for, and they send their corrections up to the internet, and we basically log in and download that, or not download, but we log into their server, and those base corrections can get used on our rover, since we're kind of signed in, I guess. And these network providers, they vary by state and even inside of states oftentimes. And there's a couple different kinds. There'll be single baseline, which is just communicating with one base station, or there's VRS systems that do a little better on long baselines because they're able to use multiple base stations to create this virtual reference system, or this virtual base station that's nearby. So the important thing when you're looking for NTRIP network providers is, if you're signing up for service, you need to make sure they're sending out corrections over NTRIP using RTCM3 messages. So there is a chance that they might send them out as RTCM 3.2. I think I've seen some networks that will do that, which the RS2 can't handle at this point. So again, when you're looking for NTRIP providers, if you are looking for them, then make sure they are sending those messages, sending RTCM3 messages. So there's another thing we should talk about, especially because Emlid offers this NTRIP caster. And what this is a communication portal. So you need internet on a base station, you need internet on your rover, and this NTRIP caster will send your base station information to the internet, and it'll also allow your rover to pull this down from the internet. So what this does, again, you need something on each end. It's helping you cast over NTRIP, or using NTRIP protocol over the internet. So you still need a base station in this sense, and you still need a rover, whereas NTRIP service providers are providing the base station. So keep that in mind. The NTRIP caster is just that. It's a portal to communicate over the internet, rather than an actual service that's giving you base corrections. Now, OPUS here in the US, you can send your data to OPUS to process a single point. So from 15 minutes to 2 hours, or up to 8 hours, I'd say, you can leave a base station or leave a receiver stationary. We can then send this file to OPUS, and they can process that single point very accurately. So basically, we could create a known point if we don't have one, or can't establish one more easily than using OPUS. It's a free software. Again, you upload to OPUS, and they send you back an email, usually really quickly. Usually the data is available, within a few hours, sometimes longer than that, and they do refine the data over the next day or week, I think. But in any case, typically you'll store data for, let's say, an hour for rapid static, upload that data an hour or two later, and get a solution 5 or 10 minutes later. So jumping right into the RS2 initial setup now. So we're going to download the REACHVIEW app on our mobile device. There'll be the blue icon, which is, there's two, there's REACHVIEW and there's REACHVIEW 3. We'll start with this REACHVIEW app, and we'll move into REACHVIEW 3 a little bit later. So we're going to turn on the Reach RS2 and wait for it to broadcast. So that's when that LED to the left of the power button is solid white. At that point in our mobile device, we can go to our Wi-Fi section, look for the Reach broadcast, the Reach internet access, and we'll find it's going to be named Reach 8537 or 8D56 or anything like that, but I'll always say Reach, and the password will always be lowercase Emlid Reach, and we're going to connect to that. And on many Android devices, especially the newer software versions, you might see a pop-up. Here you can see at the top that says Reach has no internet access. Tap for more options. This is normal. The Reach is not connected to the internet. We are just connecting to the Reach over Wi-Fi. So it's just a one-to-one connection there. at this point. But we do need to tap that box for more options, and we need to say yes, we want to stay connected to the Reach network. From there, we can open up the REACHVIEW app and press on that Reach button there. We may have to press the arrows in circle, that refresh button, but when we're connected to that Wi-Fi, we should be able to jump into the Reach and open the app. On first connection, you're going to see just this. It'll have a test checkbox that'll be checked right away, and it'll ask us to enter our Wi-Fi. So I'll press that little blue button, enter a network name, and you're going to have to manually type this in and manually type in a password. Double check, spelling and capitalizations are correct before saving and attempting that connection. Once you do attempt that connection, you receive that message, Reach is connecting to another network, switch to Joe phone to continue. That's the name of my hotspot. So at this point, what we'll do is take a look at the RS2 and take a look at that LED to the left of the power button. It should be blinking blue because it's scanning for that Joe phone network that I had it connect to. And in 30 seconds, it will either turn solid blue, telling me that it's connected to that network, or it will turn solid white, saying it couldn't connect to that network for some reason. Chances are, a password or the network name is incorrect. We just need to go back in, connect to that Emlid Reach Wi-Fi network, jump into the REACHVIEW app, and retype in our password and our hotspot name. That's typically there. But once we do connect to Wi-Fi, then our RS2 will actually have internet connection, and we'll want to also connect our mobile device to that same internet connection. That'll allow us to communicate. So on our mobile device, I'm going to go in and connect to my Joe phone hotspot because that's the same hotspot my RS2 is connected to. So now we can go back into the REACHVIEW app. We can refresh that page and jump in to the Reach. So now we have that checkbox on our Wi-Fi. Checkbox on the time sync will come up immediately as well, and we can press the Update REACHVIEW button there. So it'll take 5 to 10 minutes, and then we will be able to see this new message, reboot, and go to the app. So we'll press on that, and we get this message, Reach is rebooting and has been disconnected. So the RS2 now is, like I said, rebooting. So what's going to happen is you can take a look at the RS2, and to the left of the power button, the LED for the Wi-Fi will be blinking blue. It'll be looking for that Joe phone hotspot again every time it powers up. So if it sees it, then great, it'll turn solid blue, and if it doesn't see it, again, it'll turn solid white, and we can jump in and ask it to look for that Joe phone hotspot once again. But in this case, it will immediately find the Joe phone hotspot, connect to it, and we can jump back in, refresh that page, and jump into the app. So here's what it should look like once you're actually updated and in. You have a signal noise ratio graph showing. It will show a bunch of different satellites, and if we're receiving them, and if we're connected to our base, it will show base satellites, the number of them, as well as our number of rover satellites. You also see below in the solution status, that'll tell us if we're single, fixed, or floating. But other than that, that's about it for the REACHVIEW app in terms of that kind of the main settings. But we'll jump in. We'll still use this Reach app for the base and rover settings. So we'll go into the base settings right now. Just a few to change to get us started. So we'll go into the RTK settings, change a couple things. The base mode settings, we'll go over that, and we'll use the logging settings. And that's really only needed for if we're doing any sort of processing after the fact, like OPUS processing. So for the base in the RTK settings, we're going to set our positioning mode to static, so we're not moving. The mask angle and SNR mask can stay the same, the defaults. GNSS select. We're going to want to track GPS, GLONASS, Galileo, and Baidu, QZSS, unless you're in India. We really don't need to track that. the update rate can stay at 1 hertz. That's the default. And in the base mode, we're going to communicate with our rover over the LoRa radio. So we're going to make sure our corrections output is on, configured to LoRa radio. Frequency is not all that important. What is important is you jot this number down so that the rover will be on that same frequency. We'll set the output power full, and our air data rate, the default is 9.11. Only reason to change this is if you are having any kind of distance issues, you might want to turn this down, and that will kind of help maintain a connection over LoRa radio over further distances if we reduce that rate. But the default rate there is 9.11. Coordinate input mode. So if we're setting up over a known point, we can change that to manual and we can type in our coordinate. If not, there's a couple different ways we can do it. If we're not so concerned with global accuracy, we could average a single. So that's going to take 10 minutes, or you can put it down to 0.1 minutes, and you could average a single solution. Your global accuracy is not going to be great, obviously. It might be 5, 6, 7 feet off all the way around pretty easily. And another input mode that could be useful is to input a RTK fix or to average an RTK fix. So that is also possible. And same rules apply. Will average an RTK fix over a certain number of time. And obviously, what you're going to be doing is connecting to NTRIP and averaging that because obviously this is for your base station, so you're going to need some sort of corrections from somewhere else. In terms of messaging, these are TCM3 messages. Again, we can kind of leave all these defaults just as is. And for the base settings, the one thing I'll note is we'll want to log raw data for OPUS in REACHVIEW version 2 rather than 3. For whatever reason, the REACHVIEW version 3 is not working with OPUS at this time. So just keep that in mind. Make sure raw data is set to REACHVIEW 2. With that, we'll jump into the rover settings, and we'll deal with the base rover configuration and the network rover configuration. We'll start with the base rover. 2 areas to change settings: RTK settings and correction input. In the RTK settings, our positioning mode will be kinematic. We can leave those mask angles, or SNR mask and elevation mask angles, as their defaults. GNSS select, same as the base station. We could turn off QZSS, and the update rate, the default is 5 hertz. And the other area for the rover we're going to want to change is the base correction, or the correction input. So we're going to get our correction input over LoRa radio. The frequency is going to be the same as we set it to on the base, 902. Air data rate should also be the same. So this should be 9.11 as a default. And that's all we need to do for rover in a base rover configuration. You don't need to worry about all the other settings there. You can pretty much turn everything else off. So now to the rover settings as a network rover. RTK settings will be the same. Kinematic, turn QZSS off. Update rate can stay at that default of 5 hertz. The correction input, we are going to want to get our corrections over NTRIP. So as soon as we type in this address and port, it should download the mount point options, that is. So there, the mount point options, for me, the one that makes most sense, or I use most often, would be DRS RTCM3. And you'll very likely have different mount points than I do, or guaranteed to if you're outside of Ohio, and they might be called a number of different things. If you find something that says BRS RTCM3, that's probably what you should use, because we are communicating over RTCM3 messages, and VRS, that virtual reference system, tends to be the one you'd probably want over any single baseline, depending on your situation. But you can always contact your NTRIP service provider and They'll more than likely be able to walk you through or talk you through what you might need for your typical situation. Your NTRIP service provider will also give you this username and password that you'll need to enter. And the only other thing to note here is if you are using connected to a mount point with a virtual reference system, check that box to send NEMA messages, which is required for VRS. So once you're getting corrections, whether it's over a local base station or over NTRIP corrections, in REACHVIEW you should see this screen, gray bars being the base satellites and the colored bars being your rover satellite signal strength. And you can see there rover 33 satellites are visible, base 17 in this case, and you can see solution status is fixed. When you do get a fix, it will also play a tone on the RS2, and when you lose a fix, again, it'll play another audible tone to let you know. With that, we'll move to REACHVIEW 3 as our surveying app, whereas the REACHVIEW app was really for setup and initial settings changes. So in the REACHVIEW app, or REACHVIEW 3 app, it's going to look pretty much the same. We can refresh the page and press on the reach icon, and that'll bring us into the app. And we can, on the bottom there, move to the survey screen and then tap the plus button to add a new survey. When we do this new project, obviously we can name it, add a description, and we can choose our coordinate system. In my case, the preferred system is Ohio North in feet, and using geoid 18 for me. Inside the REACHVIEW 3 app, once we've created our project, we can press that add button on the bottom to store a point. Here we can set pole height will be number 1, and we'll want to actually type in exactly just that, the pole height. It will calculate the reference point from there. We can also calculate or change the averaging, so it averages a point over 5 seconds, 10 seconds, 30 seconds, whatever your preference is. And once we press that collect button, it will begin to store that point, averaging those observations and giving you that RMS value on the right there, and then storing the point. Once we've stored a couple points, or at least one point, we can press on that point on the map and we can stake it out. So that will give us a distance and direction and bring us to those points for stakeout. And those are really the two functions in REACHVIEW 3, storing a point and staking out a point. There's a lot of different other applications out there. If you need to do more, which you may often need, then take a look around or ask us and we'll point you in the right direction. We offer, like I said, Field Genius, we talked about that earlier. That's going to be able to do more of the kind of typical survey data collector. But there's others out there as well that are compatible. So feel free to ask us and we'll let you know what's out there. So the last thing in REACHVIEW 3 is exporting points, and we can also import them. That'll be as a CSV file. I'm sure more formats to come, but for now, that's the limitation. With that, we will open it up to question and answer and take from there.